we do conjugates. But in general mathematics, you hardly see conjugates. Meaning, they will always give you the question in such a way that the denominator will never be a root. So you not even get the concept of even rationalizing anything or conjugating. You rationalize in general mathematics, but we don't use conjugates. So they always make sure that the denominator is not an expression like this. So someone can even have this in general mathematics. You see, you are free. But once you have this, it means general mathematics application, you have to do conjugates. And we hardly see these things in general mathematics. So take note. Good. Okay, let's look at this question. We have 4 plus root 5 all over 3 minus 2 root 5. I've been asked to express this like this, meaning I have to solve this question. And I have to make sure that a root 5 should appear in my answer. And I should be seeing something like a number attached to the root 5. And it should be separated free from another. You see what's going on here? Good. So I have this. I can only solve this by multiplying by its conjugate. The process by which we multiply a surd, the denominator of a surd, by the numerator and by the denominator again is called rationalization of surds. So we are ready to rationalize. So the conjugate of this is this. Take note. But if you have a single number here like 4, you don't need any conjugates. Now, let's look at it. 4 by 3, that will give you 12. This same 4 by 4 by 2 root 5, that will give us 8 root 5. So take note. So this, we'll multiply this. This was to do the same thing. Remember the pattern, right? Good. Now root 5 by 3. You are going to get 3 root what? 5. Now root 5 by 2 root 5. If you're not so sure of yourself, this is how it looks like. 2 root 5 by root 5. This is outside, it remains outside. Root 5 and root 5 all double up, right? So root 5 by 2 root 5 will give me 2 root 5 all squared. All over. Now 3 by 3, 9. 3 by this, that's outside, that is 6. 6 root 5. Now minus 2 root 5 by 3. This and this will give me minus 6 root 5. Now minus 2 root 5 by 2 root 5. Outside 4 root 5 all double up. Please check whether everything is clear. All is clear. Good. So if you are multiplying sets, you have to be careful. That's what we are getting here. Now 3 by 3 is 9. 3 by 2 root 5, that is 6 plus 6 root 5. Take note, not minus. Plus 6 root 5. Good. Now minus 2 root 5 by 2 root 5. No, I think I'm here. This against this. Oh, okay. Now here, minus 2 root 5 by 3. You get minus 6 root 5. Minus 2 root 5 by another 2 root 5. You get minus 4 root 5 all squared. Now let's follow from here. Okay, so there is 12 plus 8 plus 3 all root 5 plus 2 times 5. Why 2 times 5? If you square square root, the square root disappears all over. Now, this and that will give me 0, right? We are off. So we have 9 minus 4 by 5. So there is 12 plus 11 root 5 plus 10. All over 9 minus 20. Good. This and this combined together, that's 22 plus 11 root 5. All over minus 11. Now what do you see here? What you see is this. That is if you can see. Now this will give you minus 2. This will be minus 1, you see, root 5. Good. Now, what if you don't bring the 1 here? You don't take time, you can't tell whether the Q has appeared. You see, 11 going to 11, you have 1 for free. That's 1. Good. Now, they say P and Q are real numbers. They are real, right? They're not fake. Now, let's quantify them now. So, this implies P should be -2 because P comes first, as you can see. Q is attached to the root 5. So, who is attached to the root 5? That is this. And the root 5 happens to be the root 5. Yes. I've really simplified and left my answer in the form they expected. Good. You are welcome to radical equations and the surds. Radical equations. Okay. So, how do we treat them? Let's see. I want to get 2 sides of the equation. So I'll first move this 64 over here. And the 64 crosses this equal to sign. What you see is this. I want to get rid of this square root so that I can free my x. What will I do? I will square both sides. So take note. Anytime you want to get rid of a square root, square both sides. Why both sides, not one side? You have 2 sides of the equation. And you are doing something for one, not the other. It doesn't go. So you square both sides. Please, I'm not going to cube root both sides. That is x minus 3 cube, not x minus 3 cube root. Very careful. If it's a cube root, you'll have seen the 3 here. So I have to square both sides. Now let's square both sides. Over here. Let's square both sides. X minus 3 all squared, as I said. 64 all squared. So try getting 64 squared for me, right? Now let's go. So when you square both sides, the square root disappears. So what is 64 squared? Okay, 4096. Now how do you solve this? The same old pattern. When I have this, it forms a root on this. Hope you remember in the other videos. Good. When I have this, it forms a cube root on this. If you have 4, that's a quarter root, okay? 5 penta root, 6 extra root, lepta root, whatever. So let's see this. That is x minus 3 equals what? Cube root of 4096. This cube root, the 3 is very small, so it will not become something like 3 times the root. Now, what is the cube root of 4096? One that? Cube root of 4096? 16, right? We have 16. How do I get my x? Wow. See, it's very simple. That is 16 plus 3. Finger counting, 19. So that is our first question on radical equation. Now let's look at our last question on radical equation. This is the last question. Let's look at it. Now I think this is more complex or complicated than the other one. I have 3x plus 4 s plus 5 equals 1. Okay. I did a long stretch. Now the first thing to do is to rearrange. Let's rearrange for security reasons. I'll carry the whole of this over there. Let's go. That is 1 equals, okay, there's 1 plus this. Good. Now, there's a trouble here, right? With the roots. So I have to square both sides. Square both sides. So let's square here. 3s plus 4. Now that is 110. It's 1, right? consider them as 1. That's all. That's why I group them to make the work easy. Good. Now, what do you see here? The square root disappears. I hope you know that. So you have 3x plus 4 equals 1 squared. I know 1 squared. That is still 1. Okay. Now, okay. If you like, you just maintain this like this. Let's do them like this, right? Let me just write this. 1 plus this. We will use perfect squares approach, right? We'll double up in the sum. Okay. So we have 3x plus 4 equals 1 plus x plus 5. 1. Another 1 again because it was a perfect square. Double up. That is it. Now let me focus on the right. 1 by this is 1. 1 by that, you get this. For security reasons, let me put the 1 there. Good. Now this by this, you still get this. So now this by this is this. All squared. Good. That is what we are seeing here. Now I have this and this will produce 2 root x plus 5. Good. This outside this 1 plus 1 is 2. I factor 1 of this. Plus the square root will disappear here. Good. Wow. The pressure is going down. Obviously, now we do what we call rearrangement. I have 3x plus 4. Now, I bring this, I'm taking them over there, right?